So we're going to calculate the standard deviation and the relative standard deviation, and hopefully in this calculation demonstration you're also going to better understand the purpose of the standard deviation. So first, what are the ingredients we need in order to calculate the standard deviation? Well, we need a situation with data. And our situation is going to be paint. So imagine yourself working for the DuPont company. You've been tasked to develop two different varieties of paint, say paint A and paint B. And imagine that you develop those paints and you actually use 10 samples of each paint to try to estimate what the average drying time was going to be for each of these paints. So paint A, if you can see here, has a mean or average dry time of 2.5 hours. And you went out and painted 10 samples of paint B, and you can see that paint B has an average dry time of 2.5 hours. So the situation is, you want to recommend to your boss which of those paints you should use. And if all you look at is the mean dry time of each of those paints, you really don't have any discriminator to tell. And so you might be tempted to flip a coin and tell the boss whichever paint happens to show up on your coin flip. And as you'll see when we look at the data, if you told your boss paint B, she's probably going to be very unhappy. Because if we look at our sample data from each of the paint varieties, we can see that paint A, every single sample of the 10 samples was dried in 2.5 hours. But look at paint B. A large variety of dry times, all the way from 1/10 of an hour at the minimum to a maximum of 15 hours to dry paint B. Obviously, there's too much variation in paint B to use it for any application as opposed to paint A, and I would definitely want to recommend paint A. If all I did was look at the mean, then I would have possibly made an incorrect or very poor recommendation. So the idea is, in this situation, that the standard deviation is a value that allows us to, with a single measure, get some insight at the variability of the measures in our data set. So let's look at the number and then we'll show how to do the calculation. If I were to find the standard deviation for paint A and the standard deviation for paint B, I would end up with these values. This repeats the mean for paint A and paint B, and you can see the second number for paint A and the second number for paint B are what this software calls S, or the standard deviation. And we see a standard deviation of 0 for paint A. What does that mean? That tells us that there is 0 variation from the mean in my data for paint A. Paint B has a value of 4.48 plus some change. And what that tells me is, this measure of standard deviation, that there is some standard deviation, some variation in the data for paint B. Specifically in the units of drying time in hours, that tells me, the standard deviation 4.48 for paint B tells me that on average, a sample of paint B will vary about 4.48 hours from the mean value of dry time for paint B. So why does standard deviation matter? Because it gives me a measure of the variation in my data.